In this video, we'll be looking at angles in circles and in particular the alternate segment theorem. So what the alternate segment theorem says is that the angle between a chord and the tangent is equal to the angle in the alternate segment. So in this example here, the straight line is a tangent at this particular point. So the angle between the chord and the tangent, which is theta, is equal to the angle in the alternate segment, which is this one here. Similarly, if I'm looking at the situation from the left-hand side, then the angle between the chord and the tangent is phi, and this is equal to the angle in the alternate segment, which is over there. Let's look at a brief example. We need to find the value of x here, giving reasons. So we start by labeling the angle here as theta, and we can say that theta is 180 minus 63 and 42. This gives an answer of 75 degrees. The reason is that we've got angles in a triangle, which we know they add up to 180 degrees. And now that we've got that theta is 75, let me annotate my diagram here. We can easily conclude that x should also be 75 because we've got the alternate segment theorem. This is the tangent, and this is the angle here in the alternate segment. So x is 75 degrees, and the reason is the alternate segment theorem. In this example here, we need to find the unknown x, giving reasons to justify our workings. So we start by noticing that we've got an isosceles triangle here. So if I label the angle here as theta, then we have that theta must be 40 degrees. And the reason is that angles at the base of an isosceles triangle are equal. We can then proceed in labeling the third angle in the triangle here as phi. So we know that phi must be 180 minus the 40 and the 40 because angles in a triangle add up to 180 degrees. This gives a result of 100 degrees. I will just state the reason that angles in a triangle add up to 180 degrees. So let me annotate my diagram. We found theta to be 40 degrees. We found phi to be 100 degrees. So I can easily proceed in calling this angle here to be alpha. And therefore we have that alpha is 180 minus 100, which works out to be 80 degrees. And the reason is, of course, that angles on a line add up to 180 degrees. And then we can easily see that the angle x here is equal to the angle alpha, which we found to be 80 degrees, and the reason is the alternate segment theorem. So we simply need to state that x is 80 degrees, and the reason given is the alternate segment theorem. In the second example, we need to find the value of the unknown y, which is the angle shaded here. I will start by calling the angle here as theta. And we know that theta together with the 5x minus 5 should be equal because it's the alternate segment theorem. So theta is 5x minus 5, and the reason is the alternate segment theorem. And then if we know that theta is 5x minus 5, then we can simply add up 1, 2, 3 here to set them equal to 180 because they are the three angles in a triangle. So we have that 5x minus 5 plus 6x minus 3 plus the 45 should be equal to 180 degrees. We said the reason here is that the angles in a triangle add up to 180 degrees. So if we proceed in solving this equation, we get that 11x plus 37 is 180 degrees, which leads to 11x being 143. And therefore, if I divide by 11, I get that x is 13. This means that the angle theta, which was 5x minus 5, is 5 times 13 minus 5, which works out to be 60 degrees. We also gonna label the other angle here as phi. So phi together with 6x minus 3, the two are equal because of the alternate segment theorem. So I can simply say that phi is gonna be 6 times 13 minus 3. This works out to be 75 degrees, and the reason is the alternate segment theorem, and therefore we can simply see that y is phi plus theta, which is 75 plus 60, and therefore this works out to be 135 degrees. Now, to prove the alternate segment theorem, let's start by considering the tangent here at C. We've got the triangle ABC in the circle. I'm going to call the angle ABC here to be theta. So ABC is theta. And then I will consider the center of the circle O, and I will draw the radii from O to A and from O to C. We start by noticing that the angle AOC, the angle at the center, should be 2 theta, because angle at the center is twice the angle at the circumference. So we have that AOC is equal to 2 theta. Remember, we're providing reasons here because we're constructing a proof, and we've got that angle at the center is twice the angle at the circumference. We can then proceed into finding an expression for angle OCA. Remember that the triangle OAC here is an isosceles triangle because OA and OC are both radii. So we can say that angle OCA is 180 minus 2 theta over 2. This works out to be 180 over 2 minus 2 theta over 2, which simplifies to 90 minus theta. The reason is that angles at the base of an isosceles triangle are equal. So I will annotate my diagram. Angle OCA is 90 minus theta. Now we also know that angle OCT here is 90 degrees. So OCT is 90 degrees. The reason is that angle between a tangent and a radius at the point of contact is 90 degrees. And therefore we have that the angle ACT, the angle here, will simply be 90 minus 90 minus theta. This simplifies to 90 minus 90 plus theta, which is just theta. So we've just proven that ACT is theta, which is equal to ABC. So this angle here is equal to this angle here, and this is the alternate segment theorem. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.